Welcome. Today, we are examining the critical issues and solutions in reinforced concrete structures. Our focus is on visual documentation of defects, testing procedures, and the sophisticated methods used for structural rehabilitation. These images represent crucial case studies in civil and structural engineering. We begin with the most common form of deterioration, corrosion. Here we see ultra-realistic shots of corroded steel rebar and the resulting spalling concrete. The expansion of rust exerts immense pressure, cracking the surrounding concrete. This necessitates thorough inspections, like an engineer using a cover meter. We must also document initial construction errors, such as misplaced or bent reinforcement bars, which compromise structural capacity from day one. Further construction quality issues include bent bars and honeycombing, a visible sign of poor concrete compaction with exposed aggregate and voids. Congested steel makes proper concrete placement nearly impossible. Look closely at the details of an incorrect lap splice and undertight steel, both of which fail to properly transfer tension forces between bars. Rebar touching the formwork results in inadequate cover and an immediate corrosion risk. Poor anchorage means the steel cannot fully develop its strength. We also see issues with insufficient bar spacing, hindering aggregate flow, and potential failure scenarios like bar buckling or the severe deformation of an overloaded beam. Moving into condition assessment, here are examples of widespread slab corrosion indicated by surface rust stains. The primary causes are often environmental, like chloride attack from salts. To quantify the problem, engineers perform field tests. A carbonation test determines the depth of neutralized concrete, while the half-cell survey maps corrosion potential. We use non-destructive methods like the GPR scan to locate hidden reinforcement and potential anomalies. Precise data is key. An engineer using a cover meter accurately measures the concrete protection depth. The rebar locator helps confirm bar positions. Every defect must be mapped, as shown in the detailed crack mapping on a slab. We often document the surface symptoms, such as significant rust staining and severe beam spalling where the steel is fully exposed. Environmental factors dictate the repair strategy. Water damage is a major contributor to corrosion. Structures facing coastal exposure require special protection against salt spray. We also account for specific threats like chemical exposure in industrial settings and damage from freeze-thaw cycles. This brings us to material solutions, starting with the use of epoxy-coated rebar for enhanced protection. Other specialized materials include galvanized steel and the superior, non-corroding stainless steel rebar. For existing steel, we apply a protective anti-corrosion coating. Where cover is insufficient, a structured concrete cover repair is necessary. For critical strength requirements, we implement advanced techniques like applying CFRP strengthening, carbon fiber reinforced polymer sheets. Structural repairs often use polymer mortar for its bonding and durability. If rebar is too damaged, it requires rebar replacement with new bars. All work is executed according to a detailed structural strengthening plan. On-site, meticulous rebar detail checks are performed, comparing the actual placement against the design through rigorous drawing verification. Quality control is paramount. We see a QC meeting where engineers review the work. This is followed by detailed inspections, a comprehensive slab inspection for cover and corrosion, and a specific column check and beam detailing review to ensure compliance. Advanced engineering includes failure simulation visualization to understand and mitigate potential collapse modes. Understanding failure mechanisms, such as crack propagation in concrete, informs the repair. Diagnostic tests like the rebar pull-out test and documentation of bond failure confirm material performance. Our goal is to achieve a professional standard, which we visualize in a repair comparison, showing the transformation from damaged to protected. The result of diligent work and advanced engineering is the final rehabilitation of the structure, a visually pristine, fully functional, and protected reinforced concrete asset ready for its full service life. Thank you.